boys and girls, we're going to review what perpendicular lines are. Last week we learned what parallel lines were, and they're lines that never intersect, which is a fancy way of saying that they never meet. They go on forever and ever if they're lines, or if they're line segments, they just go in, up directions and they never meet and they stay the same distance apart. Perpendicular lines are different. They're lines or line segments that meet at an exact 90-degree angle. So if you look right here, I inserted a picture of a protractor too that I'll refer to as well. But if you look at where these two lines meet, this is where they intersect. This is one line. We'll call it line A. Oh, nice and neat. And this is line B. Line A, you can see, is vertical, up and down. Line B is horizontal. Now, these would be an example of two perpendicular lines. They're perpendicular because where they meet, when they meet, right here, where I've circled, they form a 90-degree angle. And sometimes instead of just saying, like the number 90 degrees, which it sometimes does say, and you might see this, and then you would infer, oh, yep, that must be perpendicular. You'll notice that there's a little box here, which shows just a perfect 90-degree angle, because this is what 90-degree angles look like when you measure them with a protractor. So you see, kind of made like a dotted little angle with my protractor to show you that this would be where the 90-degree angle is. This would be an example of perpendicular lines. And I say lines because notice that on each of them, A and B, they have arrows on both sides showing us they go on forever and ever in both directions. Now these two lines, let's call them line C and line K, just for fun. Line K we can see here, line C we can see here. We know that they're lines because they both have arrows on either side. We can see right here where they meet or intersect, they form a 90-degree angle. So these would also be two examples of two perpendicular line segments. When they meet, which they're supposed to, unlike parallel lines, they form a 90-degree angle. So now let's say I ask you to determine whether these two lines, let's call them L and M. We can call them lines because we can see that they have arrows on either side, which show that they go on forever and ever in both directions. We have to determine if these are parallel or perpendicular. Well, I can tell that they're not parallel, and that's because I can see that they meet. They're not the same distance apart. Here they're this distance apart, where at this point they're further apart, and I can tell if it continues to go, they're just going to get further and further apart. So we know that they're not parallel. Now we have to ask ourselves, are they perpendicular? Well, they do meet, and we can see they meet right here, but that's not a 90-degree angle. If we refer back to our protractor, 90-degree angle usually forms, that's a little messy, but usually forms a bit of, where you can see a box, and that's kind of your clue that a 90-degree angle has been formed. So we don't see that. This doesn't look large enough to be a 90-degree angle here, and here it looks too large to be a 90-degree angle. It's way too open. So these would be neither parallel nor perpendicular lines. The secret word is couch. Finally, we want to determine if these two lines, we can call them line C and line X. We want to determine if these are parallel or perpendicular or neither, or just intersecting lines, just lines that meet. Well, I can tell that they're not parallel because just like the last time, we can tell that they're not equal distances apart the entire way through. This is definitely wider apart than this point. And if we can tell if they keep going on forever and ever, which they will because they're lines, they'll only continue to get further apart. So they're not the same distance apart. So that's one clue. We know they're not parallel. Are they perpendicular? Well, let's look. Here's where they meet or intersect. There's no telling that that's a 90-degree angle. If it's at 90 degrees, that might be a clue. Or if we saw, just like last time, well, this is not my neatest work, but that little box usually is our clue that tells us a 90-degree angle has been formed, and we don't see that. So these lines C and X would not be an example of parallel, nor would they be an example of perpendicular. So to review, perpendicular lines or line segments meet at exactly 90 degrees. A great little hint for you, if it doesn't have like the number 90, would be these little boxes. They kind of are a clue that a right angle has been formed, or thinking about what it might look like on a protractor. So perpendicular lines meet at exactly 90-degree angles. If they don't meet at a 90-degree angle and they just kind of meet randomly like this, they would just be intersecting lines.